Almost 3 years ago, when I was 12 years old, I went to the doctor for chest pain. I'd had a small encounter at the bus stop a month prior with a kid who thought it was okay to cut right in front of me in the bus stop. And me, being the stubborn little middle schooler I was, pushed back with all the strength I had. Picture two kids, except one substantially bigger and stronger than the other, fighting to get on the bus first. Spoiler alert, I didn't win. But when I got home that night, I started to notice some pain in the right side of my chest. It wasn't that bad though, so I continued on with my life, until it came back, worse than ever. After I had to be rushed home from school because I couldn't breathe as a result of the pain, the doctors finally ran some scans and reported back to me and my parents that it was just a hairline fracture with a minor blood clot. Fast forward 2 months, I went back to the doctors for a set of follow-up scans. Everything was going to be just fine, except it wasn't. And that night, me and my parents got the call that would change our lives forever. The doctor said that there had been a mistake while reading the first set of scans. The blood clot actually wasn't a blood clot at all. It was a cancerous tumor that was now 13 centimeters wide. So there I was, at the mere age of 12, diagnosed with Ewing sarcoma, a rare bone cancer. A word I couldn't even pronounce, let alone know what it meant. I quit school and immediately started an intense treatment plan, consisting of several months of chemo, radiation, and a surgery to try and get rid of the tumor. I spent almost every other week at the Dallas Children's Hospital, just sitting in a bed with blankets that felt more like towels, hooked up to an IV for days at a time. But the thing is, it wasn't just me. Babies, children less than 3 years old, were in the same situation as I was. Looking back, I don't think I quite understood the gravity of what I was going through. My parents, on the other hand, started to research endlessly to leave no stone unturned on what they could do to help make my treatment as quick and effective as possible. There were so many words flying around as we read about countless new types of therapies and treatment options on the rise. We learned that the standard treatment plan that many patients undergo today have been virtually the same for the past several decades, while the severity and volume of cases has only been on the rise. An estimated 19.3 million new cases were diagnosed in 2020, the year that I was diagnosed. And this figure is only expected to increase. Projections from the National Institute of Health show that 30.2 million cases will be diagnosed in 2040, less than 20 years from now. For this reason, now more than ever, it is crucial to start boosting and innovating discoveries and innovations in the field of oncology. And with the rise of new technologies, it won't be hard to start developing them. So the first technology I want to talk about today is AI. Now, we've all heard about AI through things like ChatGPT and those cool humanoid robots that we see on TV. But I want to talk about how AI can transform oncology as we know it. AI has the potential to revolutionize many areas of society, from healthcare and transportation to education and entertainment. Specifically, AI can revolutionize the way that we detect cancer. The use of AI is enabling the review of mammograms to be 30 times faster with up to 99% accuracy. When a cancer is detected early, it is typically smaller and has not yet spread to other parts of the body, making it easier to treat and more likely to be cured. Unfortunately, our current system of detection is far from perfect, and a huge part of that is due to the room for error while reading these scans. AI can help by analyzing large amounts of medical data and identifying patterns that could be indicative of cancer. This can include data from medical imaging such as mammograms, MRIs, and CTs, as well as data from medical records. Also, since oncology patients undergo routine scans to help with tumor staging, AI can reduce healthcare costs while improving patient safety by reducing the amount of harmful radiation they are exposed to through these frequent scans. In one study conducted by the Department of Electrical Engineering and Computer Science at MIT, a deep learning model, or DL, was created and tested in order to develop something more accurate than the current clinical breast cancer risk model. It identified patients at high risk and placed 31% of all women in the high-risk percentile, compared to only 18% by the industry standard Tyrer-Cuzick model. Additionally, the use of AI can even reduce racial bias in detection. In the hybrid DL model, it produced accurate results for both African American and white women, while the Tyrer-Cuzick model produced uneven results. Without the accuracy of AI, it is expected that 10 to 20% of all cases of cancer are misdiagnosed. And these mistakes and misdiagnosis could be life-threatening. I myself dealt with this issue. If we had known about the tumor by the first scan, my life would be so much different. I would not have had to go through so much radiotherapy and chemotherapy that basically destroyed my immune system. Sometimes I think about what my life would have been like if the cancer had been caught early. What if the doctors figured it out by the first scan? What if I had gotten more of my middle school experience back? What if we could have done more? This cycle of what-ifs has been grueling for both me and my family. But I've come to realize that I am lucky. For me, it wasn't too late. But for so many other people, these mistakes became fatal. This is why it's so important to start developing these technologies like AI that helps with the early, accurate detection of cancer. Now, I've already talked about a discovery that can revolutionize the way that we detect cancer. But let's move on to the next stage, the treatment. There are so many ways that cancer can be treated. And one of those is through the use of gene editing technologies that have the ability to alter the genetic makeup of cancer cells by allowing doctors to target specific genes that are involved in the invasive growth of cancer. Let me put this into perspective for you. Say you're working on a document and you suspect that you've misspelled a word. You can simply use the find and replace function to identify all of the typos and correct them with just a couple of clicks. Within our DNA, this function is carried out by a system called CRISPR, or in tongue twister format, clustered regularly interspaced short palindromic repeats. CRISPR is a specific gene editing technology that has the potential to increase accuracy and precision by allowing doctors to target specific genes involved in the invasive growth of cancer. One approach to using CRISPR in cancer treatment is through the development of CAR T cell therapies. In CAR T immunotherapy, researchers can genetically modify T cells to have receptors that recognize and attack all of the cancer cells. The FDA has already approved the use of these therapies using traditional gene technology back in 2017. And since then, it has proven to be an effective approach against cancer. With the combination of CRISPR, researchers are hoping to make this an even more powerful tool. Now, although gene editing technologies are great in terms of accuracy, we still do need to be careful and be cautious when developing these technologies. There are so many unknowns in terms of long-term accuracy and safety that we need to be careful about. But with careful testing and continued research, gene editing could become a powerful tool in the fight against cancer. The war on cancer is one that has been stagnant for quite some time. We need to fight back. So many people suffer from this, and it's time that we start to do something about it. Today, I stand here almost 3 years cancer-free. But there are still so many other people that are still fighting this battle. And we need to help them by developing and funding technologies that can increase the accuracy and effectiveness of treatment. We can help them, and we must help them. The war against cancer has cost us millions of lives, and we cannot let it cost us anymore. Thank you.